Hey everyone, I thought I might go through a couple of the problems from our F3 quiz for you. I looked at the quizzes for those that have completed it, and I'm just going through the most commonly missed problems on each quiz. So watch this video just as a review of those problems and let me know if you have any other questions.
All right, I'm going to go through some of the most commonly missed questions on the F3 quiz for the honors students. So question 9 said, an object is on a frictionless table. There are 3 people pushing it with an equal force. 2 people are on the right side of the object and 1 is on the left side. And then it says, what direction is the net force? What we should always start with these questions is drawing our force diagram. So force diagram has the dot for the object. It says that 2 people are on the right side, so that's going to be, let's say, on this side. We're going to call that the right side. And they're pushing on it. So that means they have to be pushing to the left. So here's the push from person 1. Here would be the push from person 2. And then there is 1 person on the left side, so that's going to be over here. And they're also pushing, so they must be pushing to the right. So that's the push by person 3. Which direction is the net force? So to figure out which direction is the net force, we can just look at our diagram and see where are there forces that cancel each other out on either side, and where is there maybe a leftover force or a net force after we cancel everything out. So I would say that this one cancels with that one, and then we have a force pushing to the left left over. So the net force free body diagram or force diagram looks like this, where we just have one force pushing to the left. So the correct answer there would be left. Which direction is the net force? 14. The mass of the box shown is 5 kilograms. What is the acceleration? All right, for this one, what we want to do, if we want the acceleration, we're looking at our equation that says the acceleration of an object is related to the net force acting on it divided by the mass of that object. So in order to calculate acceleration, we need this net force. So to get the net force, first thing you want to do is assign a direction for positive and a direction for negative. Generally, with this curriculum, they're always assigning that to the right is the positive direction and to the left is the negative direction. So that means that any force that's pointing to the left has a negative in front of it, and any force that's pointing to the right has a positive in front of it. One thing to note is that the choice of this coordinate system, which direction positive and which direction is negative, is completely arbitrary. There's no convention in physics about which direction is positive and which direction is negative. You get to choose that. So really, this question would have been better written and presented to you if it had defined that positive was to the right and negative was to the left, so we had very consistent answers. So for the net force, I'm going to add these all together now. I have positive 500 newtons plus a negative 300 newtons plus a negative 400 newtons. Or you can think about adding the negative as just subtracting. So 500 minus 300 minus 400, all in newtons. So when we subtract these, we're going to end up with a negative 200 newtons. There we go. And now what we do is we take this 200 newtons, put it back into our net force, into the equation for the acceleration. Divided by the mass of 5 kilograms. So I ended up with negative 40 meters per second every second as the acceleration. Now, since this question did not include the coordinate system, I think that you can make an argument that if you gave your answer as 40 meters per second every second, maybe you flipped this coordinate system. You defined that negative was this direction and positive was this direction. We'll be careful when we present problems in the future, but generally in the curriculum, they are assuming that to the right is positive and to the left is negative. All right, last one is number 18, trickiest one on the test. All right, so we have an airplane that has a mass of 10,000 kilograms. It's experiencing some drag, some friction due to the air of 2,000 newtons. So if we look at our force diagram, let's assume that it was flying to the right. If it's flying to the right, then that air resistance or friction that it's experiencing always opposes that direction of motion. So this is going to be that drag, and that's equal to 200,000 newtons pushing to the left. If the pilot wants to slow down from 120 meters per second to 90 meters per second in 1 minute, what force should she have the engines exert? So basically, we know that in order for her to slow down, we need there to be a greater force opposing her direction of motion compared to the force pushing her to the right. So there is a force pushing to the right, but it is less in magnitude than the force pushing to the left. So this is going to be the force by the engines. And we want to actually quantify exactly how much is that force. So remember that in order to figure out a force, we're going to need to know the overall net force on the airplane here in order to achieve the acceleration that they want. So let's start from the equation that F net is equal to the mass of the object times the acceleration that it experiences. So F net is going to be the 10,000 kilograms. And then we need the acceleration. So a side note here, remember that acceleration is your change in your velocity over the time that it takes you. And we want this to be in units of meters per second every second. So to calculate the acceleration, I'm going to take their final velocity, which is 90, subtract their initial velocity, 120, and then divide by the amount of time in seconds. So it was given in 1 minute, but we know 1 minute is 60 seconds. So we'll do that calculation real quick. So we got negative 0.5 meters per second every second. And basically on this problem, it sounds like they've defined that the right direction is positive and the left direction is negative. Or at least that's what I chose when I decided to calculate the acceleration this way with positive velocities. Okay, so we have this acceleration. We're going to put that in for our F net here. So we have the mass times the acceleration. Multiply those together. So the F net needs to be negative 5,000 newtons of force. So if it's going to be a negative net force, that's consistent with what we've drawn here, that overall this opposing force has to be greater, the winning force, compared to the forward force. So last step is that we know that F net is the combination of these forces, so we can write a little expression for that. The F net is going to be a positive force from the engines, and then a negative, so I'll just subtract, force of drag. So then I'm going to substitute in negative 5,000. Let me shift this up, make sure you can see. For the net force, we already calculated that. We're solving for the engines, and then we want to put in the 200,000 for the drag. All right, last thing I need to do is just some algebra. So I want to solve for the engine, so I'm going to add 200,000 to both sides. And we end up with 195,000 newtons is the force by the engines. So there is your final answer.